Yes, Seema, I will be reviewing the assignments. I've uh, uh, gone through your assignment quickly, and I'm yet to do a bit of thorough review. So Abhinav's question is, Pig will support Perl kind of a regular expression or Java PCRA, if I understand, is the Perl format, right? Or Java style regular expression. Yeah. So Pig supports basically the Java style regular expressions. Okay. It basically uses the Java libraries to do the matching. All right. Now, so should we start now? I think there are enough people now. Great, great. So recording has been started and there we go. So yesterday we talked about the basics of Pig and we talked about joins and even yeah. So Abhinav, if you have a question, just drop me an email. I'll try to reply as quickly as possible. Okay. And all right. Great. Great. So how do you guys like Pig? I mean Pig Latin? Is it clear to you? All right. All right. Yes. Yes. So yes, it is definitely easier than MapReduce. That I completely agree. All right. Now, so since it works on maps and reduce, it can't be used for real-time thing as of now, but theoretically it can work. Okay, theoretically it can work. So a real-time thing, for example, we'll discuss in session number 9, Apache Spark, which provides a similar concept like our dataset, and we do operations on dataset in Pig. In Spark you have RDD, and then you do operations on RDD. RDD is like resilience dataset, same thing, exact same concept. So theoretically, language wise and concept wise, it can be used. It just so happens that the underlying implementation is only for the current Hadoop's MapReduce, and that is why it is, because of the Hadoop's latency. The Hadoop's MapReduce, specifically MapReduce, not Yarn. The MapReduce as a concept was built to handle petabytes of data, and the focus was on the resilience instead of the speed, instead of the delivery speed. That is why the difference, but that's not of the fault of Pig. Okay, syntactically things look pretty smooth. It looks pretty useful in other frameworks also. All right, any other questions? Yeah. So say for example, if you have Cassandra and you are using say Cassandra storage, then it will be running this stuff on Cassandra. Okay. Yeah, you're right, exactly. And that is where the pig's philosophy comes into play. Pig as a philosophy, they said that it should run on almost any platform. It lives everywhere. Okay, so moving on. So we talked about the basics of pig Latin, loading the data, iterating using for each, filtering the data using filter, then doing order by, then sorting the data, then doing group by, and then aggregating using for each, and doing sampling, limiting the output, and storing the data somewhere. Okay. So so all of that we have covered so far. Now, all right. Yeah. So Amit, that's right. And so we talked about all of those things. Now there is a little bit of something new. So parallelism is the basic premise of pig. Okay. So basically the pig is designed for performance. Okay. So and it also gives you more and more knobs to control the behavior, right? And say for example, you can control the reducers by using a parallel keyword, and where you can define how many reducers you want parallelly. Okay. And so you can see that the parallel keyword is used when you are talking about a function which requires the reduce, which has reducers. Okay. So the parallel keyword, as you can see, like group by daily, and then we say parallel 10. It will do your job in 10 parallel reducers. Okay. And also note that we do, like in MapReduce, we do not control the map side logic of pig. We do not control the mapper side logic, right? So a common question which people ask is how do you control the default number of reducers? Okay. One is that you define a parallel syntax. You can also say that in my whole script, wherever we are creating reducers, always create 10. Okay. So by using a syntax like set default parallel as 10, right? So that is one way you can apply the script wide, rather than on every statement, rather than suffixing every statement with parallel 10, we can say set default parallel as 10. Okay. So another common question which people ask is, what if you don't apply parallel 10? What will it do? Okay. What will it do? So the answer is, whatever input data you have, it will create number of reducers per GB. If you have 5 GB data, then it will create 5 GB of reducers. Although, as you can guess, that during mapper time it has no clue about what data is going to go till the reducer. Okay. Therefore, because it cannot figure that out, therefore it tries to guess that if the data to the map is going to be huge, then the data which will reach till the reduce phase might also be huge. Okay. So based on the initial file size, it tries to predict the number of reducers. And of course, this will not be a great way of doing it, because Pig has no way of figuring out how many reducer ideally it should be creating other than the input size. Okay. And as you know that while launching a map reduce job, you have to upfront tell to Hadoop that these many reducers we want. Because on the map side, the bucket creation, as you saw that on the map side itself, the each mapper starts creating n number of buckets if you have n reducers. Therefore, MapReduce need to know upfront that these many reducers we want, right? And therefore, when Pig is scheduling the job to Hadoop, it has to tell that these many default reducers need to be created. Okay, and the default number of reducers, the way it tries to depict is by the size of the file which you are loading, the size of the in the load statement, whatever is the size. Based on that, it will try to predict the number of reducers. So if you have 50 GB file, so there are going to be 50 reducers. Okay, but if you have 2 terabyte data as input, the reducers will not be 2000, instead it will be 999 at most. Okay, it will not be 2000, instead it will be 999. Oh, I did not notice your questions. Now, oh, okay. So is my voice audible to you now? Okay. So I was explaining the default number of reducers. Okay. So should I repeat the whole discussion? Because in last 3 to 4 minutes, that's what I did. Okay. Okay. So yes. So there are a few things I told. One, Pig tries to predict number of default. If you do not tell how many reducers Pig need to create, it does some reasonable guesswork. Okay. Why I call it guesswork, you will understand now. Pig basically tries to predict number of reducers based on the data which is fed in your load statement. Okay. Based on the size of the file, it will try to predict the number of reducer it should create. If you have 10 GB data as input, then number of reducers will be 10. If you have 100 GB, it will be 100. But in case you have 2 terabyte of data, it will not be 2048. Instead, at max, it will not be 99. It will not be beyond 999. Okay, that's a restriction Pig has created. Also, this behavior of creating number of reducers can be further overridden by using your own class. You can create that user defined function to predict the number of reducers. All right, now all of you would actually question that first, why can't I mean, because Pig is trying to do the predictions on the data which is input to the map. Why can't it do these predictions on the data generated after the map phase, right? Why can't it do that? Okay, so because the data which is input to the map phase is not necessarily what is reaching till the reduce phase, right? You remember our questions of character frequencies. It was a very small data that was going reaching till the reduce phase, right? So all right, so in the case of frequency computation, you would like to have only one character frequency computation. You would like to have a single reducer. It's not a big deal because it doesn't have to do much. Okay, even though you have 2 terabytes of input, a single reducer will do the job. All right, So number of reducers, when we call a number of reducers means total number of machines on which your reducer is going to run. So, okay, so the whole idea about default reducers is clear. Let me answer your question. Is the reducer a logical unit? Data node is a physical machine. So, data node is a process on which data node is a process, and the task tracker is a process. So basically it's more of a process rather than a, yeah. So parallel number cannot be greater than number of machine. Not necessarily. What will happen is, say you have said 20 reducers and you have 10 machines. What will happen is, first it will run on these first 10 machines, then once those things finish, then it will run on another 10, the same 10 machines, next set of jobs. Okay. All right. These are very good questions. All right, let me make a note of it, because so what is the main criteria to guess how many reducers to deploy if we have to code parallel? Very good question, Sushant. So as a thumb rule, what you do is you try to figure out how much your the node on which reduce is running, how much time is it taking. Okay. uh, all right. And overall idea is to reduce the time taken by the network plus reduce phase. So total time taken during network transfer and the total time taken in the reduce phase, the summation of the two, you have to reduce it. Okay, you have to reduce the total time in that. Okay, because number of reducers, creating number of more reducers will not impact map phase too much. It will not bother map phase too much, although there will be slight bit of difference it, but it will not. But if you increase number of reducers, suddenly the time taken in the network transfer multiplies. It multiplies by number of reducers. If you have two reducers instead of one, the time taken will become twice. If you have three reducers instead of one, it becomes thrice. So it multiplies the time taken in the network transfer, or maybe more, because there are so many network traffic generated. Because each map phase has to transfer. If you have n m number of mappers and r number of reducers, so total number of transfers are n into r. All right. So as you increase the number of reducers, your network transfer keeps on increasing, but the the multiple nodes will do a better processing. So as a thumb rule, if your data is smaller and your processing of the data doesn't take too much time, then then you should have a smaller number of reduce phase. If your data takes a lot of time to to do the transfer, lot of time for processing on the reduce phase, you should keep on increasing number of reducers till the time till the point the the time taken in network plus reduce phase, both this time starts increasing. Till the point it starts decreasing, you should keep on increasing reducers. The general way is do a sort of a binary search in number of reducers. Okay, and take a reasonable guesswork. Okay. So Abhinav says that my voice is breaking badly again. Can you hear me? Hello? Okay. Okay. So, all right. So, Abhinav, I was trying to explain that how would you reach to a optimum number of reducers? Okay. So, say you have a network time tn, okay, plus time taken in the reduce phases r into, I mean, time taken in reduce phase is summation of all times. Okay. Time taken in reduce phase 2, time taken by second, third reducer. Okay. Or maximum of these three. Okay. Maximum of these three. You basically tries to m- minimize it. Okay. So objective is to minimize this. Okay. So you try with r equals to 1, then say r equals to some reasonable guess you take, and then and then see, did it decrease from here or did it increase? Okay. And then you double it, and then you keep on doing a binary jump, and you will have a clear idea on, you'll have a clear idea how many reducers you should take. Okay. So if your job runs every day, then you can actually do this sort of experimentation, other than doing a little bit of guesswork. Yeah. So if you increase R, if you increase reducers, okay, it the TN will network transfer will increase. Time taken for the network will increase. So you don't generally choose where the reducer run. Okay, you don't choose. That is the job of your yarn, the resource allocator. It does a lot to figure out which machine is free. Okay. All right. So if you increase number of reducers, then it increases. Okay. All right. So let's move on. Does map reduce output will also tell the network time? Yes, it does. Yes, it does. Sushant cannot hear me. What is happening today? Because here the network is good. Let me shut down my home theater. No, no, that was just I was shutting down my home theater. Okay. No. Actually, Sushant, you did not miss much because I did not explain anything after that. All right. All right. So I think now the voice is good and I don't have to worry much. All right. So we were discussing about the number of reducers. So hope this is clear to everyone. Should I move on? So you can basically either you define parallels on every statement where you are expecting the grouping or sorting order by or group by, and or you can set in the application wide number of reducers. Okay. All right. Now this one I think is quite obvious. Will it generate any reducer code for each? Quick, quick, quick. Will it generate any reducer code? Great. And does parallel clause have any impact on this? All right. Good. Now there is something called flatten, just like group by. So let me show you some group by first. Okay. So if you have a smaller input, so if you have this kind of a text file, okay, and you create group by, okay. Now let me run pig minus x local and say owners equal to load using pig loader and say what does it say? Yeah. Oh, I'm actually confusing hive and pig. It has to be this. All right. Now, if you say dump owners, good. Now, if I say group owners is equals to group owners by $0. Okay, and dump grp. So now you can see that, as you can see that grp basically contains something of that sort, right? You got the idea? So this is what we get if we group it. Okay, so if you group your data, like, let me go up, let me go up here. All right, if you have this kind of data and group it by column number 1, so cat and dog, both of them have come together here like this, right? Similarly, in case you want to take it back again in the same format, you will do a flatten. Okay, you will do a flatten like this. Okay, so you can say like this, and you can say here as grp. What was our syntax here? Yeah, grp only. So we can say for each grp, for each grp, generate the name, okay, and flatten the language. Now, if you see the, before we get into the nitty-gritties, describe grp. What does it have? So grp, essentially this is grp, okay, this is basically our grp, okay, which was group our owners by $0, which was the name of the owner, okay, and it essentially created something like a group. So it created a new set of map, okay, it created the new set of output where there is a key whose name is a group and the value is a byte array. So this is basically on the column on which we grouped our elements. This is the key on which we grouped our elements, and these are the owners. Okay, owners are further a bag. Sorry, this is not a map, this is a bag, and similarly owners are a bag here. Okay, now if you have to go back to flatten, okay, let's say flt equals to for each group generate 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 the group name, which is $0, and flatten the owners. Okay, generate group comma flatten owners, and say dump flt. Now you can see that it has been flattened out the way it was. It is just that the group name is coming again. If you if you go ahead and do it like this, if you just ignore the group name, right, let me just put it here and then say dump flt. Now you'll see that exactly what we had inputted That's what we get as an output. All right. So hope this is clear to you. So flatten is essentially just the opposite of group by. Sounds good to you? All right. So that's what is our flatten. Now, what do we do to get Adam, cat, dog? Let me see what you're talking about. You want to see Adam, cat, and dog, right? Now, when you were iterating over here, what you could have done is you just choose, okay, right, right. So what you do is here while iterating, you generally say for each group generate name and dollar name and owners dot name and I mean it should be like this, generate group and owners and dollar one. Okay, let's call it dedupe. Now let's have a look at what we get. Now you can see that we have picked up only the second column out of owners. Out of owners, we have just picked up the second column. So it's just a little different format from what you're expecting. Sounds good to you? And then in case you don't like these variable, the, these curly brackets, you can further say to tuple. Okay, and this will convert your bag into a tuple. Sounds good? Okay, so this syntax is clear to everybody, right? So the moment we do group by, when we say group something by, it generates two columns. Okay, first one is called group. Okay, and basically it generates something like this. Uh, so whatever value you have put here, the value of that column, okay, and the this is going to be a byte array by default if you have not specified a value, and the other one it will create with the same name. Whatever is the name of your group, the field is going to be the same, and this is going to be a bag. Okay, bag of things. So whatever is there here will have the same number of columns. All right, so that's what it is. So try it by yourself couple of times, and by the time the way Sushant has come up with one problem statement that can Abhinav has come up with a statement, and actually both of you came. Now if you try to do that kind of thing, you will have a clarity on, you will have a thought clarity on what is a hash map and what is a tuple and what is a bag. Okay, not hash map, what is a map, tuple, and a bag. Those clarity will only come if you try by yourself. Okay, all right. So do a little bit of churning of data here and there and try to get yourself comfortable. The example which we have taken in this class is for the complex data type, go to data folder. Don't delete the data folder. Go to data folder and pick up the baseball file that will make you comfortable. Okay. Maybe you copy this file to somewhere and then you do that. All right. So make yourself comfortable and because this will go a quite long way. All right. So that was flatten. Now, like with any programming language, you need to have a way of customizing the language itself. Like in Java, you can write your functions rather than only using the library defined functions. Okay, so pig also provides you a way of defining your own functions. Okay, so the first way it provides is that you can call a library function from Java as it is. Okay, you can call a library function as provided by the standard libraries. So you can define a function like hex and then say that this is my Java function. This is a static function actually. Integer.to hex string is a static function. It takes an it returns a string and takes an argument as integer. Okay, so if you want to use some of the Java function, you can use this way. Okay, now you can, once you define a function, you can call it again and again as if it's a library function. As you can see here, we are calling the hex function which we just defined, right? Now if you have your own Java function, you can use that one as well. and and this is actually a way of using a function, okay, which is not static. The only difference is it has to have this class in a certain format. Okay, we'll show you that format. So we register our jar and we define a function like this, define convert, which is essentially a class called currency converter, which takes two arguments as the constructor arguments, and afterwards you can call this function called convert on each of the values. All right, so that is how. So is it compiled separately on all nodes? So it doesn't get compiled, it is just we are making the call to the library functions. Okay, it's like the way we, one programming language is calling, your program is calling a library function of some other, so you don't need to compile it. All you need to do is just compile it on local machine, upload the jar, and then run it on the upload the jar onto the server and then register it. Okay, and when you run it, it will automatically upload this jar on all the nodes, and once it is done, it will just remove it from the distributed cache. Yeah, basically the class file. All right, now the next step here is similar to what we have done using Java. You can also call your Python function. Okay, just like your import, the way you import your class file, your file, and then say that use that full um, class as bball, and you can make a call to a particular function using bball dot function name. Okay, so that way you can call your Python function as well. All right. So an example of how to work with this is here. I'll show you. Here you can see in the pigudf test, all you need to do is say say here we are creating an upper function. Okay, this is the example of UDF we are talking about. So all you need to do is define your class extending eval function, and after you're done with it, you create a function called exec. So for every function you want to use in your pig script, or in pig Latin, you have to have a separate class for that. Okay, so here it is. So we created upper function, and then we start using that upper function wherever we wish to use. All right, the only thing is it has to have, if you remove this here, you can see that it'll ask you to create add unimplemented method, which is exec you have to have in this class. Okay, so you create exec, it gives you tuple, and under the tuple, this is the input tuple for each tuple you want to execute, and then tuple you check what is the value and then get the value. After you get the value, then convert it to the string, and whatever you want to do you can do here. Okay, any sysout you do here goes into the logs, you can check it there. Okay, and and once you are done with it, you basically say export and then jar, and that's all. Okay, so create a fresh project, and all the jar files which are this would be available on our course page. Okay, this whole project will be available. All it requires is pig.jar, not this is, so the paths which it requires is, one is pig.jar, and that's all. Okay, that's all it requires. So this need to be a separate library in terms of the separate jar file, and once you are done with pigudf jar, you can basically, I'll show you that. So we have this data, and I'm on local file system. So we have pigudf.jar, the same jar which we just created. It is already uploaded, and now I can say here, say load, sorry, register pigudf.jar. After that, what you can do is, once you're done with it, you can define a function. So Okay, now cat people. Okay, load p equals load people, p1 equals to for each p generate upper, and then say p dot dollar zero. Okay, dump p1. All right, so we just created our own jar. We basically have this upper function, which we can, as soon as we register, we can start using that one. So what does it do? It basically converts whatever is your input into uppercase. Let's see what happens. Okay, so all we did was first we did register pig udf.jar, and then we said p equals to load people, and then we said p1 equals to for each p generate upper p dot dollar. Okay, so it's doing something, it's going through this data, and probably the time it's taking is because it might be uploading the data here and there. So it does give us some errors. It says map only, the job has failed. The scalar has more than one row in the output. So what exactly are we trying to do? So we did this. This is correct. All right. So here it is. Actually, this is what I was looking for. And let me see, where can I fit in? Don't worry. Here it is. So basically, this is what we do. Okay. And here you need to call it like a value. So the overall idea is correct. All right, then we say load people. Now this way we need to first go to data and then again say it. All right, now we can do and then say dump p1. All right, and also actually if there is a mistake, we need to call it using myudf dot something. Okay, you have to actually call it like myudf dot upper. All right, so that is how you generally use the value. So let's see if something works out. Yeah, this time it has worked. And also you can say myudf dot upper. Mhm. So ideally, okay, the name is myudf. My project name is whatever namespace name you give, that is the one which is has to be there. Now this will give the correct output. Good. It's just a typo. All right. So this way you can create any custom function you want using Java, as well as you can create a custom function using Python or any other way. Okay. All right. Now, so is that clear? How did we do it? We first created a class called upper by extending eval function and putting something whatever we are expecting as output here, and then you define the function called exec and with the return value as same as what we have defined in the template, and then we define the exec function like this and work on this, right? Now, all right, now there is generally another kind of problems you would face. There would be some legacy code. Okay, there will be some legacy code which you do not own, in which you cannot have Java functions here and there and define it your own way. So you will have to use those kind of scripts also. So if you belong to a finance organization or some organization where there is a traditional code which is written already by lots of people and has been maintained, you might have to use that one as is. Okay, so in those cases, just like a streaming job, you can stream your big data through any script. Okay, through any script. For example, here we are saying load my data. After that, there is a syntax called stream my dataset through a program called hidiv.pl. Okay, if you have a script called a Perl script called high dividend, you can stream your data through this Perl script. And also notice the backquotes here. Notice the backquotes here. Okay, So these backquotes are put so that in case your program is accepting some arguments, you could put single quotes here. Okay? You could put single quotes there. Sounds good? So that is basically the reason why backquote has been used. Had it been single quote, then there would have been confusion with, you know, quoting, unquoting things. Right? So, so you can stream your data through this file. The only thing you should expect from this script is this script need to be either on all the nodes. If it is not on all the nodes, then you will have to ship it. The syntax of shipping via pig is this. You define a function in at the top saying my function name is hd and this is my script, okay, with the arguments like my minus r xyz whatever, and along with that we mark that these are the scripts that need to be shipped. You can put more scripts here if there are multiple scripts that this script is depending upon and they need to be shipped, then you can ship those, but those have to be in the same folder. Sounds good? All right. So you can basically run any script. You can just pass your data through any script you want. Okay. The only important criteria is that your script should be like a Unix filter, which takes the data input from standard input and gives the data output onto the standard output. That's what it expects. Right? Just give me a second. Good. Now, this is how you can use a existing program and can ship it to every node using pig. Now, the next step is that you might have to do a little more complicated things. You might have to do a little more complicated things, such as find the count of distinct names in each city. So in Bangalore, there are distinct names as Sandeep and Vivek, and in New York, there are distinct names as John only, and the count is one. Above the count is one, right? So how would you generally do it? Anybody? So let's say we have cities dataset, and okay, let's say we have a cities database. So we say city equals load city, and this is what we have. Okay, just for clarity, thought clarity, we keep it here. And after that, we want to do the count here. So we say group. So we say G equals to group city by $0. Okay, and then we say my counts equals to for each G generate the group name and count of count of my city, right? This is what I would do. Here I did not do a distinct. Okay, I did not do a distinct. So first I'll have to do the distinct here. Distinct, distinct. Okay, and then again, I mean, what will I have to do actually? Yeah, so right now I'm using distinct as a function available, but what if I could actually use the piglet in commands? Here, when I'm doing a distinct, this thing is going to take a lot of memory. If I could again use the same uh, give the basic commands, basic distinct command provided by our pig, then I could actually, it will be better, right? That is where the nested for each loop comes into play. The nested for each loop comes into play. We can use any commands inside the for each loop. So we can say, instead of saying generate like this, we could say first put the brackets here like this. Okay, and then we could say, just like our normal flow where we generate new data set, we could say distinct distinct city, and then after that we could also say count, our counts equals to count of d, right? You can say here generate count of d, right? So this is how you could actually do a lot of magic like this. All right. So here you can use almost everything like order by, and further you can use another group by inside it, and so on. That is why it is called a nested for each. Okay, so when you are iterating over a data set, you can further iterate inside the values using for each, and then on those values we can call our normal routine things. Here basically this for each converted the values into another data set which is available by the name of city inside this. Okay, so for each one of the things, we could basically go over the values inside the group, and then act upon it. Sounds good to you? So that is the role of for each nested. Okay, so here you can see that there's a basic command which we discussed earlier, that there is something called distinct which gives us the distinct values. We can use the same one because that will convert the value, that will get converted into a map reduce job. While if you call like this, it is going to utilize the memory. All right. So try to utilize the basic commands instead of using functions, because when you are using functions like count, or if you are trying to use some other function, those functions are not basically distributed in nature. Those function itself inside do not distribute the processing further. All right. Now sounds good. Okay. So that was for each nested. Okay, so you can actually create another for each inside that one and then operate upon it. Are you guys with me? Because I don't see your response. Now As we said earlier, that pig takes care of pig takes care of a lot of nitty-gritties of optimization for you, and will also give you the handle. So for each was the first step in the direction of giving you a more control over the way you want to process your data. Okay. Now the next step, you can see that other than parallel command itself, parallel command, the next one is fragmented join. Let's imagine this. Let's imagine this. You have got two big files, one containing name of a billion people along with their country names. And there is another small file, very small file, containing the name of the countries and the the ISD code of the countries. So imagine there's 100 entries in the country code, while in the another table you have a billion entries, right? Now, if you have to join these two tables and convert it into the name of the people and their ISD code, then it would be great. But how would you do that? How would you convert this into the output? Okay. So one way would be like our fourth problem in the first session, where we tried to join the two tables, right? Creating a key on based on a country name and merge the two tables, then try to generate that, right? And the other way would be, can somebody enlighten me quickly? Other way would be where there will be no reduce at all, only the map side would be there. What would that be? Somebody quickly? Yes. One is we join it like our exercise, and the other is the one which I have been avoiding a lot. So if you have to just translate those values into another one, what would that be? Can you avoid creating the reduce phases? So actually, I'm not portraying the question correctly. Yes, yes. So Abhinav's point is yes. So load the values into the memory and then generate in the map itself the name and country code, right? Without the need of having a reduce phase at all, right? So whenever your other file is small and you know that countries are not going to suddenly change tomorrow, from 100 it could become 101. So you can comfortably load the second file into the memory, or even hard code that second file's value into the code itself and create a map and then do it, right? So that will be like drastically different, in terms of the performance. So if you have to do this kind of operations, specifically when you are trying to join two data sets and the other data set is fairly smaller, which can which can comfortably sit in the RAM of your computer, in the memory of your computer, then it makes sense to basically load it rather than doing the standard join. And exactly for the same purpose, pig provides you something called fragmented joins, or a replicated join. You can say it replicated, meaning this data is going to be replicated on all the machines on which the map is running. The second file will get copied onto all the machines on which the map is running, and the most of the work will be finished in the map phase itself, right? Now So we are loading person, and there's a name and the country, and here you can see the syntax. So whichever is the smaller one, whichever whichever the table is smaller one, you just place using replicated that side. Had the country been smaller, we could say using replicated here. Okay, sounds good. So Abhinav's question is, but in this case, will country also be part of the final join? Will country? Yeah, uh, country and code. Yeah, three things will be happen there. Then you can do a for each and eliminate a lot of things over there. Okay, it's okay to have multiple for each statement because Pig will optimize all of those by combining all the map side logic into one, and that is something an optimization Pig does. Okay, so even if you have for each 50 for each statement on the same file, it will try to merge it into single and make sure that there is no extra work involved. All right, now there is something called skewed join. Now if you have too many values for some keys while too few values for another key, right? Specifically, when you have a reduce phase, and in the reduce phase, you are getting lot of values for a key, right? In your reducer logic, you will get a key and the values, right? A list of values. Now, if your reducer is getting too many values for one key, while too few values for some other key, then we call that your data is badly skewed, and the difference is a billion times or a million times. Okay, then we call that your data is heavily skewed. All right, so in such scenarios, to avoid your reducer, the reducer which Pig is creating, to avoid those kind of circumstances, that your reducer is overloaded or reducer has memory overflow because there were too many values for a key, while so to avoid those kind of scenarios, Pig provides you some better mechanisms. Okay, that is called a skewed join. Okay, so you just mark the data which is might have, while you are joining, you and you expect there could be skewness when you're joining on a particular key, then you mark it using skewed. In those cases, it will try to try not to load the values into the memory because or try to guess, do a lot of guesswork. Okay, all right. So, although Pig tries to guess a lot of things for you, Pig tries to combine reduce phases, map phases, it tries to combine pretty well. But when it comes to reduce phases, Pig may not be that smart to figure out that these reduce phases need to be combined together, right? So, for example, when we did when we loaded our data called daily and divs. Yeah, it would do a kind of optimization to figure out that basically it will avoid the memory overflow scenarios in skew data, as well as it will try to distribute it into further reduce map reduce phases. Okay. There are chances that your output could have the memory overflow. Okay. Yes. Okay. So Sushant's question is, how does how does pig handle skewed data internally? Do you remember our one of the questions where we were saying that generate the frequently used word after a particular word, right? We were trying to generate top 5 words after that, right? Now, in that, so we were saying, say this is a cow, and we were trying to generate the tuples like this. Now, as you can simply guess, okay, let's say, this, okay? I'll be a little more sophisticated rather than using a cow. I'll be and right now here you can see that the keyword table will have a fewer values, right? So when it groups, there will be values for each key, and out of which we'll have to do some processing. So keyword like table will have fewer keys, fewer values, right? While the keyword like this or is will have millions of values. These common preposition and kind of things will have a million values, right? Here the million values would be there for this. Now, when your reducer does this job, what will it do is all the values will come as an array, and then we will try to do that. There would be an overflow. Instead of doing that, how would pig do it? In case you have marked it as skewed, it will basically form a combination like this and put one here. Similarly, a combination like this and put one here, and so on. And it'll try to break down the problem, further using this kind of a technique. Okay. And once it has figured out that these are the top 5 and this is the top 10 and whatever is the logic, then that is how it will work. So hope I have given you a very vague idea about how is it going to work. How do we handle this situation in MapReduce if we do not have luxury of using pig? So Abhinav, you also hope got the answer. I hope you got the answer. Does pig figure it out by itself or we define? So generally we define. That is when we use skewed kind of a keyword. Okay. That is when we use a keyword like skewed. If we don't use skewed, it might be loading it into the memory. Okay. Right. So for skewed data, as I told here in this example, if we did this way, my key is this, my value is this, you are bound to get the memory overflow exception. Okay. But if you try to form the keys in this way and then you do the analysis, key, that how many times this particular key has come in. Only then, say you put a filter out there saying that after this is sorted, give me only the keywords which have top these many counts, and so on, right? And then you go into the next phase of doing the computation, right? You think about it, you'll get the answer. Okay. And this we already discussed once, right? Or should I explain, or is it clear to you? I can actually draw the whole diagram of how would I break down the problem of memory overflow into multiple MapReduce phases. Or maybe you can take it as an assignment and think about it. You will be able to figure it out. Okay, just think about it. We can discuss it again. I think that will give you enough amount of time to even solve the previously discussed problem of tuples. All right. All right. So sounds good to you? Good. And all right. So let me ask you a very simple question, and understand your understanding of the sorting algorithms. So if you have a data, if you have a data that is already sorted, okay, and you want to sort it again, okay. So you did not know that your data is already sorted, it's already ordered, and you are using a library function to sort it again. Will this library function do take time, good, big, more time, less time than the first one previously, or uh, will not take any time at all? If you have n records, sorting n records was taking n log n, and again we said, so we have our data, let's say my data is this, and we are saying sorted equals to order data by id, right? Now we say resorted again, and we say order sorted by id, right? So so in these circumstances, some of the algorithms really perform bad. So as Seema's point is, it depends on the algorithm uh, used. That is very correct. So if you are using the standard binary tree BST, the if the BST is not properly done, there are high chances that the performance of the second one will be really horrible. It will be really horrible. Okay. While the first one will be n log n, the second one will be n square. This is something very important to understand. So most of the algorithms, though they have been tuned heavily to handle the circumstance when they encounter the sorted data, still lot of algorithms of sorting flunk this particular case when the data is already sorted. They really perform extremely bad, right? Though as people, I mean as humans, we are quite smart, and we would, if we are given the task of sorting it again, we'll quickly figure out that this is already sorted, we don't need to do anything. But most of the algorithms don't do that. Okay. Also, so this is one thing. Second is, when the data is already sorted, we should not need to sort it again. If we know that our daily, this data set is already sorted and then divs is already sorted, and we are trying to uh, join it again by the same key on which these data sets are sorted, then it would be better that we inform join, so that instead of sorting it again, it should uh, just use that property of the data, that this is already sorted. And this actually makes a lot of difference in your computation. All right. So you just tell that it's already sorted, just use merge. Don't sort it again, because join is inevitably going to do the sorting. So you can say that this is already sorted, don't need to do anything about it. Okay. And this will drastically make a humongous difference. So imagine this. So you had ordered this daily already. Okay. Daily was generated by ordering some data, and divs was already generated by grouping of something. And whenever we do grouping or ordering, the output is generally sorted. Okay. So you could actually use the keyword called merge. Merging two data sets is far more easier without sorting. So this will skip the sorting, right? And will make your life really easier. So these are few optimization steps. Now there is a circumstance where there's a circumstance where you have to join as well as do the grouping together. It's a very common circumstance. There are two tables, both of them need to be grouped and then joined together, and remember, and on the same key. So, and remember that grouping involves sorting, right? And joining also involves sorting, and if it's on the same key, we can actually avoid multiple phases of sorting if we can combine the two steps together. So imagine this table. Have a look at this table. We have owners and we have pets. Owners table say that this person owns this animal, while pets table says that this person, this animal's name, this animal's name is this. Okay. So Adam owns a cat, Adam owns a dog, Alex owns a fish, and so on. And the name of the fish is Nemo, name of the dog is Fido, and so on. Okay. Or it could be the other way also, that here we have Nemo, and so on. Okay. Now the objective is that we want to find out who own cats and what are their names. Okay. Who owns cats and what are the name of the all the cats people are owning. Okay. So to do that, you need to join the two tables together and then group it by the animal, right? So instead of taking it in two steps, you can do it in a single step using co-group. So when you are grouping by the same ID as well as joining by the same ID, it will make sense to do a co-group, and co-group will result in twice the performance. So hope this example is clear. All right. Now, if you have two data sets and you want to concatenate them one top of another, it will make sense to use union. So whatever input is there in A and B, if you union it, the output, the C will contain A and then B. Okay. So if you have A and you have B and you say A equals load. Hello? What happened to this? A equals to load A and we say dump A. Can you see my screen clearly? Is the font visible? All right. So if you do union A over B, that will be good enough. Okay. It's taking a little bit time. All right. So we have got A and then we have got B. B, or we can actually load this as is and then we'll see. Okay. And then we say union of A and B, and this is what you get. Dump C. Yeah. So if you just want to concatenate the two things together, the union would do good for you. Okay. So but if you are using pig anyway, why would you go from that approach? Instead, you could actually load the data using pig and just join the two tables and get the value, right? So you can see that the data of one has been appended at top of another, right? It's just that B has come above what was A, but the result is same. No, actually, yeah, B has come just above the A. It's okay. Now, say we have D and we say union A and B on schema. Union A and B. So the syntax is union on schema, and then we say dump D. What will happen is it will try to match the columns and then accordingly put the values one top of another. So A has A has one column X and other column Y. B has Z and X. So and as a result of doing an on schema, the output here will have X, Y, and Z as three columns in output, and then for the first set, for the first set, the Z column will be empty, and for the second one, the Y column is going to be empty. All right. So this is the use case of using on schema along with union. Okay. You can see this. You can see the empty after the comma here. So the Z column is a Z column is empty, and in this here the Y column is empty. Okay, so when you say describe, it shows you that D has got three columns, while describe A and describe B, right? So you can see A has got XY and B has got YZ. So it tries to, when we say on schema, it tries to fit one column over another. Okay, and and the identification is only based on the names. Even if they have different data types, it doesn't matter to pig at all. It will still group them together, even if X of the first one is integer and X of second one is char array. Still, it will group them together. All right, sounds good to you? All right. There is one more thing. Oh, there are actually quite a few things. I think we should take a break. I was thinking that. Okay. All right. All right. Let us take a quick break. All right, so I'm back. Are you guys back? Great. So, a quick question. If we say C equals join A comma B, what will be the results? Mm-hmm. Yes. Yes, it'll be an error. Okay. So, great. Great. So, what do you do in this kind of scenario? You remember we when we had to join, if you want to do something of the sort, like given a list of nouns and a list of adjectives, generate all combination of adjective and noun. Okay. So if you have a list of nouns such as, okay, boy and girl, and and you have adjectives as fast and slow, and all you want to do is you basically want to generate all combinations like fast boy, slow boy, and so on, right? And if you had to do this using SQL, what will you do generally? This is what you expect as output. Okay. So basically, you have to generate all such combinations. So what would you do in this case? Select noun comma adjective from nouns and adjectives. Perfect. Or simply select star from nouns and adjectives. Perfect. So if you have to do the same thing using pig, and our join is not supporting that kind of syntax, you go for something called cross products. Okay. And cross product again has something called parallel, which makes you do it parallelly. All right. So this is it. So this will basically do a cross product, and you can mark on how many machines you want to do it parallelly, and this will give you the results. All right. Now, since when you're going to use Piglet in, you are generally going to create a report which is going to be saved somewhere from where it will be run every day. Or maybe in your report, you want to pass different parameters or you want to parameterize your report. So for that, Pig provides you the adequate parameterization. So if you have, say you want to run your data, you want to run your daily.pig, every day on a different date. Okay, so you can define something like this, and this one is passed via the parameter. So whenever you're calling your script, whenever you're calling your daily.pig, you pass an argument like this, minus p date equals to some value. And you can create lot of such parameters and pass it. If you have a lot of parameters, your command line would go ugly. Instead, you can create a separate properties file containing the key value pairs, and then you can use that. Also note that you can back reference and form another variable from one variable. So like date is a combination of year, month, and day. Right? So, and in this circumstance, when you have moved all your variables to a separate file, you can use that using a command line argument called minus param file, and there you go. Okay. So, like with any other reporting tool, every reporting tool provides you arguments and argument substitution and variables. Pig also provides you the same kind of philosophy. Now, there is, if you have got a huge input, a single file, and you want to process this input using, uh, you want to split the input into multiple phases. Okay, one way would be you load this file thrice. Okay, say you have this, and basically what is happening here, if you have this, what's happening is you loaded web logs into this particular data set, as in loaded as in you defined your data set as load this, and after that you can split your data set into multiple legs. Here we are splitting into three data set: April 03, April 02, and April 01. And this splitting is not like standard split. It's not mutually exclusive. Okay, or it is just like a case, and it's like equal to copying the data. Okay, so whenever a record matches a condition, that one is put into the output. If it doesn't match to the condition, it is skipped from a particular leg, and so on. So there could be a scenario that a record doesn't go into any of these data sets. Similarly, there could be a scenario that a record goes to more than one leg, and so on. Okay, so if you want to split your data into, now it will generate three data set at the end of it. So you have got three data sets. Now you can do filter, group by, and all sorts of things on top of each of these data sets. Okay, and the happen split can happen on any data set. Okay, we can further split April 03, April 02, and April 01 into multiple legs. Okay, this is a convenient feature, and also it makes it possible to push the data, push multiple maps and reduces into a single one. So if you are operating something upon April 03, 02 into in the map phase itself, there are chances that the whole thing becomes a single map phase instead of multiple map phases. So those are the few optimizations Pig does for you. Okay. So that is called a split. All right. Also, this is something which we have already discussed couple of times. When we split or do all kinds of things, Pig tries to figure out the optimizations, and the execution is non-linear. As we have already told, the execution of anything depends on the end result. Okay, what is it that we are dumping or what is it that we are storing? Only based on that, everything that uh, all the other steps on which a particular data set depends will be executed if we are dumping or storing our data set. Okay, so that makes it non-linear execution. Okay, that makes it a non-linear execution. Things will not necessarily execute in the same manner in which we have mentioned them in the script. Okay. All right, so the general documentation of pig is available on their website. This is pretty good documentation. Basically it lists down all the library functions and everything, and also custom load function we have already given an example, and the same thing is also available here. Okay, same thing is also available here. And there is a you can write your functions in JavaScript as well. Okay, in the same way the way we had defined our Python one. Okay, so any questions on pig right now? Yes, are you with me? Yes, go ahead. Okay, but make sure that you try piglet in. It is actually very important to learn that. If you're going into analytics of big data, then probably pig is going to be quite useful to you. All right, just give me a second. All right, so I had some call from unknown number, and there's a reason. Good. So let's move on. So experiment a little bit more and have fun with the grunts. You will actually grunt in the beginning, but it's actually far more easier than other languages. It's pretty straightforward. Okay. And the more you experiment, the more you will learn. And yeah. Maybe. All right, so let's move on to our next slides. All right, so those who are quite comfortable with SQL would find Hive also pretty interesting, because what Hive did was make it possible to run any logic of SQL as MapReduce. Okay, so and the reasoning is very obvious. Why do we need Hive in first place? Is very obvious. As you must have noticed the same phenomena, Hadoop is great, but how do we move existing data, existing relational data, and as well as SQL infrastructure? Okay, there are large base of SQL users. Probably every person who is doing a little bit of advanced level in industry is acquainted with SQL, right? So that is the reason why the Hive and the whole phenomena is very dependent on Hive, because Hive makes it possible for lots of people to prepare analytics on top of Hadoop. Okay, and when you compare Hive and MapReduce, the answer is very straightforward. The MapReduce is even difficult for developers and lot of repetitive logic. So the value proposition is fairly clear. Now, the Hive is great for data warehouses when you are analyzing relatively static data, because Hive does not provide you a way to edit records. It doesn't have the statement like update this particular record, insert into this table, or delete from this table where x equals to y. So the record wise editing is not possible. What you can do is you can insert a whole set of record into a fresh table. That's what you can do. But you cannot do record wise editing. All right. And Hive also makes it possible to move the existing SQL queries as is. If there is a legacy code which was running on some data, you want to run the same thing after you have moved particular tables onto HDFS, you can use it very well. Okay. So the value proposition is good, just that make a note, because Hive cannot do everything. First, it cannot do the record wise editing. Second, it cannot be used in online transaction processing. Reason is very simple. The MapReduce has got a latency. Okay, it's a disk based thing. It has a latency. There's a network lag, and whenever you are executing something onto a particular task, it it basically um, runs there is a huge latency during boot up time. Okay, so that is why we do not use Hive for OLTP. But there are efforts which are going on. The companies like the companies who owns Hive, Hottenworks, they are working really hard to make the Hive very fast. Okay, they are coming up with some newer changes in architecture that will be released soon, and that should that should make it really fast. Okay, all right, so these are something which I have covered already in the previous slide. So this is great. Hive is great when you want to mine and when your data set has to be mined and is well maintained. All right, so let's have a look at the architecture of Hive. So this portion you already know. There is something called Hadoop. There's already something called Hadoop, which has got something called name node, job tracker, task tracker, data node, and all that, and on which MapReduce job can be executed. Right now, Hive basically has the heart of the Hive is this driver, which compiles the SQL, optimizes it, and then executes it in the form of producing map and reduces. Okay, and once the results are given to the driver, it represents it back to whosoever asked the SQL to be executed. Okay, now parallel to that is something called metastore. The whole SQL, the whole SQL as a language is dependent on the definition of various tables, on the whole paradigm of SQL is dependent on the fact that every table has to have columns, and all the rows have to have same number of columns, and every column has to have a data type, right? So to facilitate that kind of the metadata related to the table structure, it comes up with something called metastore. So whenever you define a table, the metastore will have all the details about this table, while the data would be actual data would be lying in HDFS, okay, which will be queried using MapReduce phase. You will see that in a minute, don't worry. So you will see that in a minute, and this driver and metastore combined together facilitate the query execution, and the way you call this query execution could be from the command line, or you could have Hive web interface, you could have a thrift service. What is a thrift service? Can anybody tell me quickly? Anyone? So thrift service, what is a thrift service? So can you hear? No. So my question is, what do you understand by a thrift service? Have you ever heard about something called a thrift service? Okay, it's not something to do with the cheap, but dictionary wise, yes. Yeah. And okay. So nobody heard about thrift at all? All right. So let me, because this is a very important concept, even if you are not into big data, it would matter to you a lot. So let us say today you are planning to launch a web service. You want to give a web service to all your users. Okay. So your first attempt would be to create a REST based service, REST based. In that, you will ask your users to use a URL saying www.yourswebsite.com/a/get stock prices. Okay, and then you give out the information in the form of JSON or XML or whatever format you want to give. Now, this REST service is good. It's simple. It is does not require a particular client, but this REST service is little inefficient. This is little inefficient. It is not thrift enough, because if you remember the XML format or JSON, it's not compressed well enough, and there are many things. And also the HTTP is not really uh, HTTP is stateless, which means if you have a lot of communication going on, you will have to multiple create the connection multiple times, and that's where the lag starts coming when you are talking to the services which require a high throughput. Okay, so to create a very high throughput service, as in when you have to have a open connection forever, and you have to do a lot of back and forth in terms of calling a service, just like when you execute a SQL query from MySQL command, it is basically talking to the backend, and the connection is open for quite some time, right? That is what that's the kind of client you want to create rather than only the REST-based system. Okay, so few people sat down and they built something called Apache Thrift for exactly that kind of purposes. So as of today, any service you are creating, you do not sit down and write your own service mechanism and all of that. You just use Thrift as is. Okay. The other benefit is that Thrift generate the clients for you in almost every programming language. You write the definition of the interface, and Thrift will generate the clients in all possible languages. So your service you just define once using Thrift interface definition language, and then Thrift will generate all sorts of clients in all sorts of programming language. Now people running their running working in Java, C, C++, C Sharp, everybody will be able to connect to your service using the client which Thrift will generate, right? So that is the objective of Thrift service, and this is quite widely used in lots of projects. Okay, it's not only Hive. There are other services also which basically expose a Thrift service to the end users. Okay. Yes, it keeps the connection open, just like SQL. Connection, when I say it's a TCP/IP connection. Okay. So this way, makes it possible. So in case in future, if you're building a service, probably have a look at how Thrift can help you, so that if you write it in Thrift, then you would not have to generate the clients in all programming language. All you have to focus on the server side, and client side will be generated by Thrift for you. Okay, sounds useful. So the Thrift server, instead of Hive guys writing their own client, they all they did was they created a Thrift service, and JDBC, ODBC drivers can connect directly to the Thrift service and get the work done. Okay, so that is a magic. That's a magic which is done by Hive. All right. Now, there are multiple systems which can contact Hive. One is Hue, other is Cubol, and there are many other. Okay, Hue is the web interface. There are multiple servers. They can talk to Hive via JDBC ODBC driver or their command line interface. All right. So this is the general architecture, and probably this kind of a design would be there in a lot of systems where you have a thrift server. Then there is thrift server exposes ODBC, JDBC, and people can run their SQL queries using their JDBC, ODBC drivers. All right. So this is again, this is a very rash way of defining how does Hive query looks like. So first, we load the data into a particular table, and once the data is loaded, we create another table onto it. So, say we loaded our plain text file into a table called docs. Once that is done, we split it. We split the data by space and put it in you know, in one set called W, and then we do a word count and then we sum it up after doing group by. So that's as simple as it can get. Now, if you want to get started right away, you can log on to Hive SSH student and then start working on it. Okay. Also, you can either call Hive from the command line, or if you just want to run one query, you could use this. You could say Hive minus E and then a select star from your table, and then whatever this is your SQL query, whatever you want to do. In case you have script written in a file, you could call something like that. Hive minus F and then your SQL file, right? So let's go into the details. Let me just see what's going on with our Hadoop servers. All right. So Hive is started. Now you can create a table, select star from the table, then drop the table. It's as simple as that. Okay. Now a, a little bit more about this command prompt. You can say DFS, just like pig. You could also execute. You could execute commands from here. All right. So this basically is HDFS commands you can run. Then you can load another script by using source, just like shell. And then commands start with dash dash. Then you have environment variables like this, and then start working on it. Okay. Also, you can execute a local command by putting exclamation and then run. All right. So that's how it looks like. Now, like with any other language, when we talk about, there is something called the data types in this language start with normal. It is started with simple, very simple data types, but Hive has ended up having duplicate data types for various databases. Because as I told you, people use Hive in order to have the people use Hive in order to port their existing SQL script to HDFS, so that they can run it on HDFS. Therefore, Hive has ended up having almost the union of all the data types. Okay, so MySQL had some data type, MS SQL has some data type, Oracle has some data type, and Hive has all of those data types. As you can see, Boolean and binary actually do the same thing. So it has got almost all the data types. Similarly, string and varchar is almost the same thing. Now, in addition to the basic data type, Hive also gives you a little complex data types. First is arrays. Arrays is, you know, the values, multiple values, which are, counted from 0 to n. And Hive also gives you a data type called maps. Maps is basically key and value. Key can be a collection of key and value. Key can be primitive types, while the value can be any data type. It could be complex or it could be the normal data type. And then struct. Struct is basically like your any object which has many key value fields where key is predefined while value can be filled in. Okay. So key is, already defined. Okay. So is it still breaking? All right. All right. Okay. Okay. So then struct is clear, I hope. Struct is, and again, struct is predefined object and you just fill in the values into that. While map can have any key and any value. And union is a different one. Those people who are from the C background, they will understand what does it mean by a union. Union is something which which can have different values. Say union, if union has says that there could be any of these three values at one time. Okay. So it, so say you say union int and string and say date. So only one of these three values will be present at one time. Okay. This is good if you want to use one particular column for various kinds of, uh, you know various kinds of actual data type, while the real meaning is same. For example, if in India we call a zip code as numeric number, while in US if zip code also has a alphabetic character to it, and so on, right? And you want to store both of these into a single column, then you generally use a union in that case. Okay. Or how should I explain? How should I explain? So say for example there is a table which stores people's ID, people's users table, which has one column called ID, the source ID from which the user has signed up with us. This ID could be a numeric one, okay? It could be a string. If it is a numeric one, that means it's an internal user. If it's a string, then it's an external user. So, but at one time there could be only one value. Okay. Okay. Yeah. You can, yeah, as I was showing you, that you could basically do either this way. After starting the prompt, you can do this way to load a particular SQL file, or you could run a SQL file like this, saying hive minus f and your query. Sounds good? Yes, yes, it will have all these data, these advanced data types. Why do you feel that it will not have those data types? I'm interested in knowing that. All right. So, yeah. So almost, I mean, Hive has tried to include these features because these features were there in Postgres. Postgres provided these features, and Hive tries to be union of all. Okay. So I have actually long back I've worked on Postgres, and I've actually worked on almost all databases. So that's how I know this. All right. So we have all right. Just like with any database, you have something called a namespace, or sometimes we call them databases, and Hive also provides you all of that, and this all constitutes to the metadata. Okay. So we can say show databases. So these are the databases. In case you are working on this, you can create your own database and start working on that. Okay. You can say create database. You can say create database mydb 24 Jan. And what does it say? It says that uh, these quotation, these quotes, single quotes are not allowed. All right. So the database is created. Now I can say use my DB 24 Jan. I remember to put semicolon. All right. Now you can say again, for some reason this thing has gone really slow. I think it's the network. And also those guys who are working from, sometimes in case your SSH gets stuck completely, you can type this and this. Tilde and dot will kill your SSH session. For some reason, my data bandwidth gone slow. All right. So now we have also you can say describe database and it will show you all the details. And also in case you want to display the current database name, then you can use this command. All right. Also you can drop the database and if you want so. All right. Now the next thing you would like to do is show the tables. We'll show you the list of tables which are there already in the database, and then uh, get data from a table and run all kinds of queries on the table. Okay. Also, a better way to understand what is going on with the table is using this format. Describe, formatted, and your table name. All right. This will show you the full details about your tables. Okay. Now, that was the basics of what is how does your hive looks like. Now let's understand the basic differences between let's understand the details which are very different from your standard SQL. Okay. So I'm assuming here that most of you are comfortable with SQL. Is there anybody who doesn't know SQL? All right. So there are basically two kinds of table in case of Hive. One is called managed tables and other is called external tables. Okay. So a managed table is something which is owned by you. When you drop this table, the data gets deleted, while external table is more like a view on top of the data. All right. Now let's understand further. Whenever we are defining table, we are basically defining all the metadata, and that metadata is stored into something called Hive metastore. And the metadata is what are the databases, what are the table names, and what is the column names in a table, what are the data types of that each column, and so on. Okay. So when you are creating a table, you generally create a table like this. Okay. Everything is good. So this is how you generally create a table. The only difference is here. Okay. Only difference is these lines. It says that this table essentially its data is fields are terminated by tabs. If you don't provide that this information, by default it will assume the underlying data of this table is separated by control A. If you don't specify tab, then by default it will assume the underlying data for this table is control A separated. And This is the location. Okay. All right. So the voice is breaking. Let me try to recycle my net. All right. So can you hear me now? Hello. All right. So already there is only a few minutes left, and so let's. Okay. So the what I was telling you is whenever we create a table in Hive, we either create something called a managed table, where if we drop the table, the underlying data gets also deleted. All right. So by default, whenever we are creating Hive table, the data gets created in HDFS only. Okay. It basically the data lies in HDFS. Okay, is it breaking again? Right. So it's not audible now? Let's continue next week. Already, I think it's already overload of the concepts. I think let's continue next week. Okay. Yeah. Okay. So the assignment for today's, I mean, this last session is basically the quiz is there on Pig. Finish the quiz. Okay. Finish the quiz, and basically the exercise you should try to do it all by yourself. Okay. Okay. So try every command which have been discussed in that session, and try to solve the 3 4 problems which we have given for MapReduce using your Pig. Okay. All right. Have a good day. Bye bye. Hi. So I forgot to tell you one thing. So in case your friends are interested, you can refer them to the session, and I mean, we generally give them a discount in case your friends are interested in the course. Okay. We generally give them 10% discount. All right. Bye bye. Bye bye, Abhinav. Bye bye, Bindu. Bye bye, Nakul.